Dear students, so our today's topic is electron microscopes, that is transmission electron microscope or TEM. They use a particle beam of electrons in order to visualize the specimen and to generate a highly magnified image. Actually, this electron microscope, it was invented because of the drawbacks of existing optical microscope. Take an example. If you pass light through a slit, it gets diffracted, and we can collect this diffracted light and we can produce the image of slit on the screen. If the slit is very narrow, then the diffraction also becomes wider. So in that case, we cannot collect all the diffracted light. Okay. So the image will become blurred. As the size of object decreases, the image will become blurred. It will become more blurred. One more point, if the wavelength decreases, the diffraction will also decreases and the resolution will be very high. And we know that the lambda, the wavelength, it is equal to h divided by mv. M is the mass, or lambda is inversely proportional to the mass. And the mass of electron, it is much higher than the photons, and therefore the wavelength of electrons, it will be smaller than that of photons. So in electron microscope, we will use electron beam instead of the light rays. Since the diffraction is less, the diffracted waves can be easily captured by the lenses. In electron microscope, we use electron magnetic lens in order to focus these charged particles, that is the electrons. Now we can see the construction of a transmission electron microscope or TEM. So there is an electron gun. It produces electron beam. The cathode coil will emit the electrons, and these electrons, it is accelerated through an anode, and this anode, it is kept at positive potential, and at the center there will be a small opening, and the electrons, it will pass through it, and the diverged electrons, it will be blocked. Next element is a condenser lens. The lenses, here we uses electromagnetic lens. When the electromagnet is switched on, a powerful magnetic field is created. Okay. The electron beam travels in spiral path that will be focused by this strong magnetic field. So here, then condenser lens will focus this electron beam to the specimen. Okay. The electron wave that pass through the specimen and undergoes scattering, and different parts of the object, they transmit different amount of electron waves. These diffracted waves are collected by this objective lens and pass to the next level, that is to the intermediate lens. The objective lens and the intermediate lens, together it is called image producing system. So an intermediate, or we can call a primary image, it is produced from this lens. Then this can be further magnified using a projector lens. So the image can be defined and focused by adjusting the current through the coil, current through the electromagnetic coils. That's the lens. Okay. And the final image, that is the magnified image of the object, and it is recorded on a fluorescent screen. Then in order to avoid external interactions, all the elements in the chamber, it should be kept in high vacuum. Now we can check the advantages and disadvantages. First, the advantages: very high magnification and resolution power. Then the 3D images can be recorded using proper recording systems. Then the main thing, the control of the image, it is much better than optical systems. Then on the negative side, so here the high vacuum is necessary to maintain the proper recording of the images. That is one of the disadvantages. And you can also note down this comparison between optical microscopes and electron microscopes. Very high magnification rate, better resolution power, proper recording system, and very flexible. Okay. In the next class, we can study about scanning electron microscope. Okay. Thank you.